Hello students, in today's class we are going to look at the perspective projection which comes in the unit 5 of engineering graphics. So in perspective projection we have two methods, one is visual ray method and another one is vanishing point method. Okay, so visual ray method is what we have in the syllabus, and we are going to cover the visual ray method in this video. Okay, so there are few components of visual ray methods are there. We will see one by one. Okay, so before going to that, what is visual ray method? All right, there is a there is an observer standing at the left and there is an object standing at the right. Okay, so in between the observer and the object there is a picture plane. In the picture plane we are getting the image of the particular object which is lesser than that of the original object. Okay, so in this picture plane we are getting some shrinked image. That's what we are going to draw. Sorry, so this is what the image we are getting at the picture plane, and we are going to draw this image using visual ray method. Okay, so as I said, we have some important components in visual ray method. What are all that? Okay, so take this example. There is an observer at the left and the object at the right. So this is the object, this is the first component. Okay, and then the object and the observer are standing at the ground plane. So first one is object and the second one is ground plane and the third one is station point. Instead of the observer, we are concentrating on the station point, which is the eye of the observer. Okay, so this station point can be denoted with respect to two planes. First one is ground plane. From the ground plane the station point is some 4 feet above or 5 feet above the ground plane, and then we have called the picture plane. From the picture plane the station point is some distance in front. Okay, so in previous orthographic projection we have a vertical plane, right? This is VP and there is an object at the center and the observer. Okay, the observer is at the here, the observer is here. The observer going to look at this object and the projection will be at the vertical plane. With respect to the plane, the object is in front, whereas here with respect to the plane the object is behind, right? The object is behind. Okay, so in previous 3 units the object is in front, here the object is behind and the station point is in front. Okay, so in the picture plane we are getting the shrinked image of the particular object. Okay, so with an example we will see the steps involved in perspective projection. Okay, a pentagonal prism of side base 20 mm and height 50 mm rests on the ground plane on its base. So here instead of the object we are having a hexagonal prism. Okay, hexagonal prism is standing like this. Okay, so hexagonal prism is standing like this on the ground, and then one of its rectangular faces 10 mm behind the picture plane. As I said, this object is 10 mm behind the picture plane and the station point is 40 mm in front of the PP and lies 40 mm left of the axis of the solid. Okay, first it is 40 mm. 40 mm from the ground. Okay, and there is an axis, okay, for this particular object. So here there will be an axis. With respect to the axis, the station point may be left or right, or maybe at the axis itself. So these are all the three conditions. So here the station point is left of the axis of the object. You can see the question. The station point is 40 mm in front and 40 mm in front and lies 40 mm to the left of the axis of the solid, and the station point is 40 mm above the ground plane. As I said, the station point is given with respect to the two planes. One is picture plane and one is ground plane. So first we are going to fix the station point with respect to the picture plane. So first we need to draw the picture plane. So from the in the top view, we are looking from the top. Okay, the picture plane, that particular plane looks like a line from the top view, and they said the object is 10 mm. Here you can see 10 mm behind PP. So first I am drawing the top view of the particular object. This is a pentagonal prism. From the top view we can see the pentagon. Okay, and then now we need to fix the, so give the naming, and then we need to fix the station point, right? So first fix the station point and then we can draw the ground plane. Okay, so the station point is 40 mm left of the axis of the solid. First I am fixing the axis of the solid. Okay, so the axis lies here somewhere. Okay, and then 40 mm to the left, and then they also said the station point is how much mm in front? 40 mm in front. Okay, so this distance also 40. This is in front distance and this is left of the axis of the solid. Okay, so now I have fixed the station point 1 and I have connected all the corners of the pentagon. Okay, this is the steps we need to follow. First I have drawn the picture plane and then the top view. Top view is 10 mm behind. So we need to draw the solid, that is the pentagon, 10 mm behind. So in previous projection, so this is in front. Usually we will draw the in front distance above the vertical plane or the horizontal plane, sorry, above the horizontal plane. Here the behind distance is coming above the picture plane and in front is coming below the picture plane. This is inverse to the previous 3 units, you should remember. So this is the behind distance, behind, and this is in front. Okay, you should remember this. So the in front distance coming below the picture plane. Okay, so now I have fixed the station point. Now I need to fix the ground plane. Okay, so this is S1, this is the station point 1, and the station point 2 should be drawn. Okay, so you have to fix another station point at a distance of 10 mm. So this station point 1 and this station point 2 is kept between a 10 mm distance. Okay, from this station point the ground plane will be 40 mm below. Okay, they said the station point is 40 mm above. So first we have fixed the station point and then with respect to the station point 40 mm below we are drawing the ground plane. So from the ground plane we can see the front view. So what is the front view of a prism? It is a rectangular. Okay, rectangular plane can be seen, and draw the visible and invisible edges. Okay, and then give naming. Okay, give naming of the particular front view and connect all the edges with respect to the S dash. So there are two station points. Okay, so we can draw two station point in order to avoid the collision of all the rays. So the top view should be connected to S and the front view should be connected to S dash. Okay, so usually we have only one station point or source point or the eye of the observer, but in order to avoid the collision of these rays, we are having two station point S1 and S dash, S and S dash. So with the S you are connecting the top view, with the S dash you are connecting all the front view. Okay, so like this we are connected. Okay, so this is a prism. So the top view is named as 1 2 3 4 and the bottom edge is named as ABCDE, and ABCDE is also connected to the S dash. Now you can see these rays are intersected by the picture plane. For example, here we have a intersection, here we have an intersection. All these 5 top view is connected to S. These connecting rays is intersecting with the picture plane. So wherever the intersection is here is appear, you need to draw a dotted line with respect to the intersection. So from edge 1 to S we are getting intersection at this point. From here I am drawing a dotted line. Similarly to second edge is connected to, second corner is connected to S, so which is intersected at the picture plane here, and from that point I have drawn a dotted line. Similarly the third corner, fourth corner, so this is fourth and 5, so all the 5 is intersecting at the picture plane. At the intersection you need to draw a vertical line. Okay, so this is the intersection line from 1. So here it will cut the ray from the edge 1 to S dash. It will be coming here, right? So this is 1. Similarly 2 is coming here. So likewise we will have 5 points. Okay, so you can see the first point. So first I have taken the third. So since this is the first bottommost edge, so from 3 to S is intersecting at the picture plane here, and I have drawn a dotted line. This intersection, this line is intersecting at the 3 to S dash, and now 4. Okay, this is the intersection at 4 and I have drawn a dotted line. This makes another intersection with the rays which passes through 4 to S dash. Similarly 5, similarly 1 and 2. So now I have got 5 points. You can connect all the 5 points, you will get a pentagon like this. Okay, now I have got a pentagon in the 1 2 3 4 5 edge. Now we can get the points in the bottom also, that is ABCDE edges. So this is the edge A. Okay, sorry, this is the edge E, that is we are getting at the 5. So 5 to S, 1 comma A, 2 comma B, 3 comma C, 4 comma D, 5 comma E are the 5 edges. So E to S is this ray and I have got the intersection here. So from the intersection I have drawn the dotted line which cuts the section E, corner E. Similarly D, A, B and C. So I am connecting the 5 points I have got. So I have got another pentagon like this. So by connecting all the By connecting all the 5 corners, the top pentagon and bottom pentagon, we will get a prism like this. Okay. So these are the steps we need to carry out to obtain the pentagonal prism and perspective projection. Okay. So there is another problem. A square pyramid of base height 20 mm and height 50 mm rests on the ground plane on its base. So in previous problem you can see the pentagon is 10 mm behind, but here the square pyramid standing on the picture plane. First the picture plane and then the top view, that is the square, and then we need to draw the station point. The station point here, it is right side of the axis of the solid. From O, it is some distance to the right of the axis, that is from O we need to fix the station point to the right of the O. So the distance is given, that is 40 mm right of the axis. Also 40 mm in front. So 40 mm in front and 40 mm left of the axis. So now we have fixed the station point and we have to connect all the corners with the station point. Okay. So with the station point, I am connecting all the 4 corners as well as the O. O is the apex. We need to connect the O also, and then we need to fix the station point. Okay. The station point 2 is 10 mm away from the station point 1. This is station point 1. This is station point 2. In between distance is 10 mm. Okay. And then we need to draw the ground plane. Okay. Here in this PPT, the order is somewhat reverse. So follow the steps as I'm saying. Okay. First the picture plane and the square, and then the station point. Station point is right of the axis of the solid and 40 mm in front of the picture plane. So this is the first step. First step is these 3, and then fourth one is S dash. Okay, S dash is 10 mm away from the S. Okay, these two should be lies in a same vertical line, but 10 mm away. And then we need to draw the ground plane. This ground plane is how much mm? 70 mm below the station point. So they have said inversely the station point is 70 mm above the ground plane. First we need to draw the ground plane, okay, and then 70 mm. But here what we did is first S, we have got S and then S dash. From the S dash we need to draw the ground plane which is 70 mm below. Okay, and then we have to draw the front view. So a square pyramid can be seen as a triangle from the front view. Okay, so the AB lies here and CD lies here. So draw the projection lines like this from A to B, C to D and O. Okay, they have also mentioned the height of the pyramid. Okay, so at this point, that is 50 mm above, we will get the apex O, and ABCD. So this is AB and CD we will get at the ground plane. Okay, and then connect AB, CD and O to the S dash. Okay, I have connected all the visible corners to the S dash. Okay, the top view is connected to S and the front view is connected to S dash. Now, what we did earlier is from the intersection, that is the solids rays, visual rays connected to station point is intersecting at the picture plane. Okay, from the intersection point you need to draw vertical line to the bottom rays. Okay, so this is the ray A, right? So this is the ray A this is the point B, okay, and this is B, this is C, and this is D, and O is also there, which is in between the A and C. This is the intersection with the picture plane. With all these 5 points, I need to draw vertical line with respect to the picture plane, okay, like this. So first A, and then D, and then O, okay. Now I have drawn only from these 3 points, that is D, A and O. Already I have drawn the projection line from B and C. So I do not need to draw another dotted lines. Okay, that is projection lines. Okay, first this is the line from the O. Okay, you can come here, and which will intersect at the rays which is passing through the O to S dash. Okay, this is the point O. Similarly, now A. So this is the intersection point at A. I have drawn the vertical line, and then this line intersecting at the ray which passing through the A to S dash. Similarly, B, C and D. So I have got the 4 sides of the square. Okay, first I am drawing the square, and with the 4 base corners I am connecting the apex. So these 3 are visible. Okay, and the behind edge is not visible. Okay, which is A. So this is coming from A. This A alone is not visible. This is capital B, this is capital C, and this edge is capital D. Okay, this is O. This is the perspective projection of a pyramid. So we have drawn the prism pyramid. Okay, so 2 cases we have already seen, and with respect to the station point, we have seen 2 cases. The station point is at the right, and the station point which is at the left. Okay, that's one more case. The station point is at the axis. So the station point S will be coming here, and below the station point 1, 10 mm away, we need to draw station point 2. So this is another case, third case, which is not discussed in this slide. Okay. So these are all the 2 important problems. You can easily get 20 marks from this unit 5. Okay. So with this, I am stopping this video. Thank you.